The manufacturing industry is becoming increasingly automated and this way achieving unprecedented efficiency. Unexpected failures, however, still occur, causing downtimes, resulting in high costs. Despite of advanced digitalization and the large number of sensors, the causes of these failures are often unknown. So the challenges the manufacturing industry is facing really lie in data harmonization, data interpretation, and model building. And this is exactly the reason why we focused our research activities on identifying whether we can use AI-based methods to predict or even prevent production downtimes based on existing production data. Magna Steyr was the first company taking up this challenge with us, with the aim of developing a prediction model for process-related downtimes.
Although our production is already highly optimized, we are not immune to production downtimes. These downtimes are not triggered by the robots themselves, as one might think, but usually have process-related causes. For example, welding guns become contaminated by nearby glued spots or by welding spatter. Together with Fraunhofer Austria, we have now worked on interpreting our data and finding patterns and correlations that can be traced back to welding-related production downtimes.
For our project Suspicion, we needed expertise from different kinds of disciplines. And therefore, we have assembled a top-class team consisting of experts from the field of artificial intelligence and software development coming from Kraftwerks, experts in the fields of robotics and mechatronics coming from Joanneum Research, as well as experts in the field of production and maintenance optimization coming from Fraunhofer Austria.
And using data and machine learning approaches to answer questions like predicting upcoming errors, it is essential to do your homework first. It's important to understand how the data is collected and what the assumptions and limitations are. We check if all requirements are met and if everything works as expected. Missing values, corrupted data, false timestamps, and so on are strong indicators that something might be wrong. In this project, we used our data and machine learning expertise to do that homework and to develop a proper prediction model on top of that. The model uses robot sensor data to predict upcoming errors in the near future with high certainty. This model prototype has been uploaded to our data science platform Navio, which enables us to use it in production right away. So all we need is live data. After connecting Navio to this input, we can predict when errors will occur in the near future.
Errors that occur within robot-based manufacturing systems are often not caused by the industrial robot itself. Nevertheless, many of them affect the robot and its behavior. In order to detect any kind of irregularities, all available sensor data of the robot is analyzed over a long period of time. Furthermore, additional features are generated based on expert knowledge that allows for even more targeted insight into the data. In particular, assessments of the motor current help to detect mechanical faults on the robot and on the tool at an early stage. In addition, process cycles are analyzed with the help of simulations in order to assign causes of faults to a specific movement pattern of the robot. This allows for the elimination of recognized weak points of the production cell through program modifications.
In this project, we have developed a generally valid model in extracting information based on existing data or data sources. So for example, at Magna Steyr, we have succeeded in predicting welding-related downtimes with a precision of 42% based on error codes and robot-specific data. Now, our prediction model will be in phase 2, where it will be further optimized and validated in an industrial setting for another 6 months. So based on our research results, we are able to apply the prediction model in a variety of industrial settings or production plants with only a small effort, adapting it to the specific industrial requirements.
The prediction model developed by the Suspicion Consortium has the potential of increasing system availability that enables us to save additional production costs. In addition, the collaboration has helped us to critically examine our processes and collect data in a more targeted manner, thus identifying specific causes of downtime. We are very satisfied with the added value that the research project has brought us.